One mistake that people often try with pointers is returning a pointer to a local variable. I'm going to show you why that is not a good idea. So here is an example where I'm trying to return a pointer to a local variable. I will admit that this is a bit of a contrived example, but it's going to make the point that we need to make. So here I have a function whose name is calculate tax. You give it some income. Apparently we all pay 10% of our income in taxes, so it calculates that, and then it returns a pointer to that variable. So the return type on this is a pointer to a double. You and I know that we would normally just return the double, but I'm making a point here. So because I want to return a pointer, I return the address of tax, which is a pointer to this variable. You will see that I get a weird warning that says the address of local variable tax may escape the function. So like it's like breaking out of jail or something. Anyway, what it's saying is tax is a local variable, and we have learned that that local variables are stored in the stack frame. It's worried that we're giving a pointer to our stack frame back to somebody else. And so that's what it's worried about, but it's just a warning. So let's just ignore it. If we run this, well, I'm already worried because it takes a while to run, which does not feel right. And then it says, process finished with exit code negative a gabillion. And there's a magic, the number makes a lot more sense when you look at it in hex. This exited with this code. If you were to Google that error code, that is essentially you accessed memory that you are not allowed to access. And I did not get my printf, so my code did not run. It's broken. So let's watch in the debugger what's happening here. So I put a breakpoint. There I'm at my main. I don't have any variables yet. I'm going to step into so that I can see what happens in tax. Here we are in tax. It has the income is 42,000. If I say step over, it's now correctly calculated that we owe $4,200 in tax. So I'm going to return a pointer to that. That seems perfectly sane. So we return this pointer to tax. When I step over that and step back into my code, now you'll see tax is a pointer to null. And you think, oh my goodness, how could that possibly be right? I returned a pointer to a variable. So let's stop this again. And let's do the same thing. I'm going to run it in the debugger. Well, I'm going to stop it. And then I'm going to run it in the debugger. And I'm going to say step into. Now I would like to see, I'm going to do step over so that I'm sitting right on the return statement. I want to see what actual code got generated for this return statement because I can't figure out how I possibly get a null in that. See this move 0 into EAX? The compiler knew that we were about to return a pointer to a local variable, and it was so frightened for us that it didn't want to let us do that. So instead, it returned 0. Which is null, and that's why when we try to use the pointer here, we try to chase a pointer that is null. That's what gives us the illegal memory access error. So I think I need to draw a picture to show you why the compiler was so upset. So let's think about exactly what that code was trying to do. Main had called calculate tax, passing in 42,000. So both their frames were on the stack. I've included the types of the variables in this picture to make a point. The variable named tax in calculate tax is a double, but the one in main is a pointer to a double. We watched calculate tax store the correct value of 42 into its tax variable. So calculate tax then tries to return a pointer to its local variable tax. That's what the ampersand, address of, operator is doing. If the compiler let us do that, then the variable that return value would get stored into is main's variable named tax. That would mean that the pointer would look like this. There is one huge problem with that. Calculate tax has returned. Its stack frame is no longer there. To be clear, the memory is still there, and our value may still be there. However, that memory has essentially been freed, and it'll be reused by any other function that main calls. In fact, the calls on assert and printf both will use that space. That means that the location that our pointer is pointing at could have anything in it by the time we go to actually print out the value. Bottom line, the compiler doesn't want to let us return the pointer to a local variable because the local variable's memory will be freed as soon as that return happens, and any other function calls could overwrite the value of tax that we put there. But one more thing. My compiler was actually really nice when it forced the return of null instead of the return I wanted. Compilers sometimes let you make these bad returns. And sometimes your code will magically work because nobody overwrote that value. However, later, a very small change in code in functions that you're calling could suddenly make you have a really weird value. Those things are really hard to debug, so I'm pretty happy that my compiler made it crash right away. My only question is, if you're going to force the code to be different than what I wrote because you're forcing the return of null, why did you only give me a warning? One last thought before you wander away. This is a great example of why you should always pay attention to compiler warnings.